I'm glad to see so many people also interested in C++ and not only the kickoff. So we can now talk about a bit more interesting stuff, at least in my opinion, because we now talk about C++. And as a spoiler, in my opinion, C++ has so many advantages compared to C. So hopefully you will have a lot of moments today where you think, oh my God, I always wanted that already in my C programs. So this is what we will talk about today. And we start with from C to C++. So we ended up with C in ESB at the last assignment. What is new now? Let's write our first C++ code. We change from our main.c file to our main.cpp or C++ file. So the file extension is different. We change our compiler from Clang to Clang++. So far, so good. We change our includes from the standard I/O header to I/O stream. We change from printf to std :cout. That looks ugly, but it is. We change from scanf to std cin. So maybe you can already see it. This is output, this is input. So let's write our first hello world. As always in a new programming language, the hello world in C++ looks like this. So we have a main again, same as in C. We include the I/O stream, and we have our hello world string, but we have this notation here. So we have an std cout with these output stream operators. There are many names for it, but I think this is the best. And what we do here is we have our string hello world, and we kind of pipe it into the output. So this output stream operator means give me this string and put it into the output. So basically the terminal, for example. And here is an std end line, basically a new line with one more thing, but we will come to that a bit later. So this is basically a hello world in C++. Looks different. I know we are used to the printf, but this is it has many, many advantages compared to the printf. When we have a standard input, we have like a variable. We still write the data type in front of it, and we say cin into the variable. So this is then the input stream operator. So we put it into the variable. Again, a bit more intuitive than the scanf, in my opinion. We really write something in my variable, and then I can write it like this, so I can concatenate this my var string with my variable name here. And I can do this with arbitrary number of variables and symbols.
So to jump into this, this means I do not need the address of operator anymore when reading from standard in?
No, in this case, I don't need it anymore.
It's cool.
We have to use it in other ways, but in this case, we don't need it anymore because we can directly write something into a variable here. Also, if this would be a string, this would also work. But we will talk about strings later on.
Maybe another question regarding standard in, standard out. With printf, we've used the format specifier.
Yeah.
Do we need it here?
We don't need any format specifier anymore because we can just write here or add the variable as it is, and this input and output operators will do the formatting for us. So they now know, okay, this is an integer, and I just concatenate it to this string here.
So it makes life easier, in my
Makes
opinion.
life a lot easier. But I know, of course, especially in the beginning, this std : cout is a bit confusing. Enums and structs, again, very similar in C, but there's one huge difference that I love in C++. We don't need a typedef anymore. In C, it was always like typedef, struct, some name, then the struct, and in the end, you have to write the name again. No typedef for enums and structs anymore. We can use it like this. Null. Null is what we often used for a pointer. In C++, there's a so-called null pointer. So null in C is a macro that translates just to 0 or to 0 casted to a void pointer, but it is basically 0, and there is no difference between the verb null and the 0 value. The null pointer in C++ is a dedicated pointer or a dedicated value for a pointer. So there's a difference between the value 0 and null pointer. And this can be an advantage because sometimes I want to have a null pointer, which just points to nothing. And sometimes I want the actual value 0. And now I can differentiate. All right, that was our first part already.
Yeah, and let's start with our first concept, which is namespaces. Why did we start with namespaces? There's a simple reason for that, because you will, at least in the practicals, actually always face namespaces. I cannot think of any case without using namespaces. So you will use namespaces throughout the practicals.
And we already saw them, but we didn't know. Now, in the last slide.
In the last slides, we have seen them, but we didn't know yet. Yeah. So namespaces are mainly used not only in larger projects, but mainly in larger projects. So you could also use it in the practicals when you work in a team. It is mainly used to organize code, and also a big advantage of namespaces is to prevent naming conflicts. We'll see that in a minute, what this means. But first, let me ask, are you familiar with Marvel and the DC universe? Is anyone familiar with that? Just a random question, because we'll use it for namespaces. So raise your hand if you're familiar with the Marvel or DC universe. Perfect, because I'm not, so...
So we can blame you now.
No, please don't blame me. But yeah, we will see it, why I've asked this question. Let's create a struct superhero. First of all, we don't need a typedef anymore. That's great. So we have the three members, name, power, and strength. But we also want to create another struct with the member weakness instead of strength. As far as we know, this doesn't work. So we cannot define two structs with the same name but different members. So how could we solve this problem? We could just use namespaces for that. So we have one namespace with a struct superhero in our Marvel namespace and one struct superhero in our DC namespace. So there can exist two different structs with the same name, but they have to be in different namespaces. So this is what we meant before when we said namespaces can be used to prevent naming conflicts. So it's perfectly fine. We have superheroes in the Marvel universe, we have superheroes in the DC universe. So how can we access these structs in this case now? We can simply use the name of the namespace. In this case, we have Marvel. Then we have two colons, as we've seen in standard, for instance, cout. Two colons, and then the name of the struct in this case. And so we can differentiate between superheroes in the Marvel this case namespace or universe, and superheroes in the DC namespace. So this is perfectly fine. This code compiles, and we can use superheroes of both namespaces. So namespaces particularly provide a way to organize the code, to encapsulate some code elements. It can be structs, it can be any other elements, and they can have the same name if they are in different namespaces. And you can access them by using the name of the namespace. Yeah, namespaces are great, but they can also be very challenging, and we'll see also later why they can be even more challenging. If you have many namespaces nested within other namespaces, you will see here that it's very hard to, for instance, access the employee ID here. So you have to write company, so it's the most outer namespace, then ; department, team, and then you can access the employee ID. So many nested namespaces can lead to a less code readability, to more complexity in the code. So it doesn't only have advantages. So use it responsibly, use it if you're sure what you're doing.
Especially in bigger projects. So maybe in this kind of project where we have 10 lines of code, it's not very efficient. But when you have bigger projects, like in the assignment 2, namespaces make sense to use.
And now it gets even more complicated. You can use the using directive to always assume that some namespace is always declared. In this case, we have the Marvel namespace that is included using the using directive. So you don't have to, thank you for that.
This one.
Exactly. So you don't have to write the namespace before the struct anymore. So you can here omit the Marvel : part and just use superhero instead of Marvel : superhero. So we now know that if you as a programmer write superhero without anything before that, that you will use the Marvel superhero and not the DC superhero. But you can still use the DC superhero by providing the namespace, : and then superhero. So this code is perfectly fine. What does not work if you use two using directives, so using namespace Marvel and then using namespace DC, and omit this part here, then the compiler will say ambiguous definition, it does not work. So be careful when using the using directive, using the using directive and using namespace, because this can even be more complicated if you use the using namespace for the STD namespace. So the STD namespace includes a lot of objects, a lot of elements. For instance, it's the cout, it's the end line, the cin, and many, many other elements and objects. So please be careful when you use using namespace STD. We recommend to not do it, so please don't do it, at least in the practicals. Also not, or be sure what you're doing if you're doing this outside of the practicals, because this will definitely lead to ambiguity. In German, it's the word Doppeldeutigkeit. So you will definitely have problems when you include the namespace with this using directive. So please don't do this in the practical.
So I always have to write std : cout, for example.
Yes, it's not that much of effort to write this, and we always know that this is the std cout and std cin, or endline, or whatever in the std namespace.
But there is a solution for that, isn't it?
There is a solution, because you can declare, again, using declare some elements, some objects of a namespace explicitly. So you can, for instance, here include using std cout or std endline or std cin, whatever you want. And then only this part of the namespace is included, and you can omit the namespace before the object or the element. So this is definitely something you can use, but also be careful when you use it. And now that we've seen endline, is endline the same thing as \n?
Basically the same. I always get this question, and I thought that some of you might ask that, so I added this. Basically, std endline is the same as the new line character, but std endline in addition flushes the buffer. That's all. There is a Stack Overflow post with, I think, 5,000 upvotes, so you can read it in detail. But the most important conclusion is std endline in addition flushes the buffer. We are fine with both if it works.
But if applicable, we would recommend to use std endline. But it's not, doesn't matter.
Yes.
Yeah, sure. So to repeat the question, if you want, we'll come to strings later. If you want to append the endline character, so \n in this case, you should definitely use \n instead of std endline, but we will come to that later.
Maybe I could also show it here. So if you have like std cout, hello, and then I can, for example, add the new line here. Or what I also can do is add the new line here, for example. This would also work.
Perfect. Then let's continue with...
Okay, auto. We will unfortunately not talk about this auto. It's German. But it will be, or it is a cool feature. So when we create a variable in C, the programmer has to decide the data type. We know that. So we have to write int x equal to 5. So we declare it's an integer. With auto, the compiler decides what the data type is. So we can say int x is equal to 5, and then auto y is equal to x. So that means this data type here is decided by the compiler. We can also use it for strings, for example. We can also use it for floats. So why not just always write auto? Any ideas? Yes? When we want to change the value, yeah, you can change these values too. So they are not constants, they are usual variables. Yes? Yes, so when we want to, so basically it's a problem when we as a programmer know more about what the data should be than we actually provided in the current state. So let's say we have, for example, it can be problematic because let's say we have an integer has a specific range of 4 bytes, and we declare this variable with auto, so we only can store integers with a, I don't know how much it is, but it is like 6 billion, something about
that, yeah.
When we know that our number will be larger at some point, we have to declare it on our own because auto will not work. That's maybe not the usual case. Let's say in most of the cases, I think auto will do the job, but sometimes, especially in combinations with pointers and the other topics we are talking about later on, auto can lead to wrong data type interpretations. But for easy ones, like we have here, you can write auto. There will be later on in the course also long data types. And with long data types, I mean the data type alone is about 30 characters long, because there are combinations of different data types in C++. So then it again makes life easier to write auto, because it saves us time writing all this long data type. But in general, auto is very useful. Yes, there's a question.
But the auto is just assignment to integer, for instance, or is it? It's
Yes.
not an auto type, right?
No, there's not a new data type. It just implicitly decides, so the compiler decides which data type from our known data type is selected. Yes.
Afterward, it's defined as an integer. You can change it.
You can change, yeah. So you can work with it as it is an integer, for example, when the compiler decides that it is an integer. But the problem is you as a programmer don't know what the compiler decides. So there is no very easy and intuitive way, like it is in Python, to know what's the data type of an auto variable. So when you're unsure, when you're not sure what the compiler have decided here, maybe you should do it on your own. And the code might be also difficult to read, because when everything is as auto, you have to think of, or you have to go to the first initialization and then, okay, what does this mean? And it's just a little bit more thinking. And when you, so at least in my opinion, when you know what you want to do, use the usual data type. Auto gives you more freedom, but also offers new errors or possibilities for errors. All right. A new concept is range-based for loops, and it solves a problem we have in C that's very, very annoying. In C, when we have a loop, we had to write something like this. So we have an array of 5 numbers, of 5 integers, and when we want to iterate over it, we have to say, okay, from integer starting I is 0 until I is, until I is less than 5, and then increment I, and then I can access it like this. This is a lot to write just for iterate over an array. In C++, we can use range-based loops. And range-based loops is a so-called for each loop. So it iterates from the first element until the last element. And it's so much easier to write, because the only thing you have to do is you have to define your iteration element, it's int e, and then this column, and then the array. It should iterate over. And then you don't have to use like this to access the array at a specific element. But what you can do, you can use it like it is this variable here. So when you write it like this, at least in my opinion, it's so much easier to read, because most of the time, I would say 90% of the time, when you iterate over an array, you want to iterate from the last element to, or from the first element to the last element. This is the main task you have to do, and this for each loop is perfect for this. It saves a lot of time. Yes? It works, so the question is it the same for allocated arrays? Yes, it works for all kind of arrays. We will see a bit later also another representation of arrays, because we won't use arrays like this anymore. There is a so-called vector we will use. That's again an improvement of arrays, which gives us again a lot of better options to work with arrays. And you can also use this for each loops for these vectors and other data structures.
I will also have another question.
Yeah.
In this range-based loop, if I now modify the value of I, is this value also modified in the array?
Oh, that's a good question. Not really, because you have kind of a copy. What you can do, but we will come later to this, you have kind of a pointer, it's called reference, to the actual element. But in this case, when you modify this I here, it will not modify the actual array. But we will come to that.
Perfect.
Yes? Yes, so the left one is also C++ code. You can actually write every C code in C++. It works always. C++ is, as the name might suggest, the improvement of C. So it works completely, C works plus the C++ implementations. So you can write it like this if you want.
Maybe to add on that, of course, you can just use this for loop here. So you can also use for loops as you know them from C. So for int, then any name. So the initialization, then you have the condition, and then you have some operations. You can, of course, use that in C++.
Yeah.
You will have to use this for specific situations.
But in many cases, I just want to iterate over the whole array. References. References is, at least in my opinion, one of the huge advantages of C++, the most important advantages, because at least on my opinion, when I learned C, pointers made me headache most of the time. So it was very, very annoying because pointers are very, very hard to understand, especially in the beginning, and references create kind of a solution for the pointer problematic. In C, when we used pointers, we had something like this. So we had an integer where we have a value, and then we created a pointer which takes the address of a variable. So this is basically what this says. So give me the address of x and store the address in a variable called pointer. And this one, this asterisk here, indicates that this is not a value, it's an address there. But what we have to do then is we have to dereference the pointer to get my output. With references in C++, it's much easier. Okay, I have again the same variable declaration, but the only difference, or the main difference here is when I create my reference instead of a pointer, I just give it the name int reference. So this is now the reference symbol. It is also the address of symbol because C also works. But when I write it here, I declare a variable from the data type integer reference. And I do not need to use here the address of operator because it knows implicitly that I want to have an reference, and I can use the reference as it is the original variable. So I do not need, there is no need to dereference it here because references are not the same as pointers, they are a bit different. So we create a reference to an integer, and this is like an alias, so just a second name for the same variable. A pointer is not like an alias. It's not a second name for a specific value. It's a pointer to an address location.
Now to make the confusion perfect, can I create a reference of a pointer?
Yes, of course you can create a reference of a pointer. You can mix it, but I think, so I at least haven't had a situation where I would need it, but it's C, so everything is possible. You can also have a reference to a pointer, but you kind of, omit the advantages of a reference because you
And the
have to
intention, yeah.
use the pointer in some point. When you work with references, so again, the same example, but now we have to increment this after we created this pointer. We again have to dereference it. We need these braces here, and we can add the plus plus. When we have a reference, we don't need it. So we don't need to dereference it. We can use the reference as it is the same variable x. So we don't need this writing, and at least in my opinion, when you write this, it is always also pain in the fingers because you need to get to the keys, and this is much easier to write. Yes. So what are we increasing here is the question. We are actually increasing the x value. So we are increasing this value here. It is not a pointer. So reference is not a pointer to x. It's just a second, let's say a second arrow to the same value. So with pointers, you always have to dereference this because it's not the value it's pointing to, it's to the address, and then you get to the value. And the reference does this implicitly, and actually you can have the value itself. That's why when we increment this ref here, also the x is incremented. Yes?
Are we allowed to make a reference to an array and then iterate to any plus one?
Yes, you can use, and we will use it in a few slides. You should use references very often, especially with arrays and so on, because otherwise they can get copied and you don't want to have a copy all the time. But we will come to that in a few slides.
Does reference really exist in the memory?
Oh, that's a good question. Does a reference really exist in the memory?
Very good question.
Not as it is a pointer, not as a pointer exists in the memory. But of course, you kind of philosophical. There is no real memory location of the reference. Let's say it like this, as a short answer. But I think there's a huge discussion on Stack Overflow about that.
So I think there's another question, yes?
Yes?
Why do we even need the reference if we could just use the x value?
Yeah, sure. Why would I need the reference if I could use the x value in this case? Of course, this is a very, very short example. Yeah, you would not need it in this case. You can work with the x, but in many cases, you will need references. And we want to break it down here in the lecture at the smallest point, so you get the concept in general, and then we will move on to more advanced topics where you actually need it. Of course, in this case, you would not need it. Yes?
Just one last question, or at least three. What happens if I dereference the reference in this case? Is it an open memory address, or is it what happens?
The question is, what is if I dereference the reference? I think it's a compiler problem then, so a compiler error, because you cannot dereference it. It's like dereferencing this x variable here. Just does not work. Okay, then let's continue. This is maybe the first application you would need references. So when we had in C, we had this call by value, and this actually did not work. So what's the output of this code snippet? It's 10, yeah, because we are handing over the x, but it's not the same value here as I have here, so it's just a copy of my x variable. I increment the copy gets deleted after the function is over, and I still have my x value 10 here. When I use call by reference using pointers in C or also in C++ now, I handed over the address of my variable. I took a pointer, I take this pointer, I dereferenced it, I incremented it. What's the output now? It's 11. So this works. And now we can use call by reference using actually references, because it is easier, in my opinion, to write. So you hand over just the variable x, but you take the reference of it. So it's not a copy of it, as it is here on the left side. It's the actual same value you're getting. You can increment it, and the output is also 11. So especially working with functions, references are a huge benefit, because it saves you writing all of this integer pointer, dereferencing, and handing over the address. You just need to declare it once that I want to make not making a copy, I want to have a reference here. And I do not have to declare it here, because I declare here I want to have a reference and not the copy from it. Any questions to this? Because this is crucial to understand references. Yes? Good question. Do we need pointers anymore? In some parts, yes, but a lot less in general. So I think in most cases, references will do the job in C++. There are, of course, some special cases, yeah, but in many cases, references will work. When you use recursion and references, okay, let me think about it. Usually it should work, but it's of course harder to comprehend, because so the compiler will not display an error, in my opinion. But of course you are always editing the same variable, and if your code works, it works with references too, yeah. Any other questions to references? So to conclude the references, use this address of or the reference operator instead of the asterisk at creating. There is one difference, and this is why I said before, sometimes you might need pointers, because references cannot be uninitialized and cannot be null, because they always have to point to refer to a value that exists. So if you create, let's say, a variable, but in this line of code, you don't know what it should point to, because the object doesn't exist currently, you would still need pointers to point to this element. Dereferencing is not needed, it's just an alias of an existing variable, but as I said, it always refers to an existing variable, and if the variable does not exist in this line of code, you cannot create a reference. You cannot write integer reference x equal to null pointer. There will be an error. Let's try it out. Is it big enough? Maybe we should make it one bigger. Yeah. Integer reference. Ref is equal to null pointer. And yeah, I should get an error because this won't work here. It always has to refer to an existing variable. This works. Okay, I have a question for you now. Let's see if you understand references now. So this is a Slido quiz, and we will do this from time to time in our lectures. There are 2 more in the next few slides, but yeah, you can scan the QR code or go to slido.com, enter this code. It's anonymous, so you don't have to log in or whatever. And you should see also this picture and I think 4 possible answers. The question here is, what is the output of this code snippet? Assuming that everything is included correctly, we have the IO stream and so on. So this works in general.
Looks like a mixture of all call by value reference methods approaches we've seen now.
Yeah.
It'd be interesting. See the output. Okay, we've already almost 80 participants. Let's wait a few more seconds.
Yeah, there's a huge discussion, and I like the discussion. It seems that it's not that easy. That's good.
Can we reach 100?
Yeah, let's wait until 100. 2 more. One more vote. Come on, we can do it. Yes, great. So you need knowledge of call by value, call by reference, and call by reference using references in this example. Everybody finished? Then let's have a look what you have voted. Oh, wow. Very good. 61% did a great job. Let's see at the solution. No, there is no solution. Why is there no solution? Okay, let's have a look at this. What do we do here? We have 3 variables, x, y, and z. The first one is a classical call by value. So this value gets copied into this, it gets incremented, but it's a different value than this x here, so it does not influence this variable here. The second one is tricky because the second one looks like it is a call by reference because I hand over the address, I take a pointer. But usually, when I want to modify the original value, I have to dereference it and then increment it. But I don't do it here. So a question to you, what do I increment here actually? Yes? The memory address. So I just increment the memory address of this variable here, which is just a local variable in this increment function. makes no changes to the original y here. The set is handed over without the address, but I take a reference, so I actually have the same address as here, and when I do ref++, I get to the same value. This last one here is the only one that actually modifies my original variable, and this is why the output is 2, 5, and 9. Any questions to this? Yes?
Don't quite understand because there's one time we reference with int and then the end, and then we do the end before the variable. And is there a difference? Or?
Where do you mean now? Here in the function declaration?
Yeah, that's the normal reference we went through. And
Yes.
then the y, if it's
In the function call, you mean, so the address of y here down below.
yeah, there.
Ah.
It's before the variable, and normally like the reference gets changed. I think with the end before the variable, I'm confused by.
So when I hand over it like this, I hand over the address of my y variable. I also take the address because it's a pointer here. So I take the address. So what I stored here in my ptr variable is the address of my y from the main function. But what I do here is I increment the address of this ptr. I do not dereference it to get to this value 5, and this ptr is not the same as y. So I do not increment y. The address gets copied into my function here. So I have here a copy, so the address of my y, and I modify the address from this ptr value. But it does not change the y at all. Any other questions? All right, then let's move on to function overloading.
Yeah, function overloading, a feature that I missed a lot in C when we did ESP, also generally when we program in C. It's a quite common feature in many programming languages actually, so I really appreciate it that we can use the feature function overloading in C++. So I'm not sure if you have tried this or something similar in C, so to have two functions with the exact same name. In this case, we have two functions with the name func. And if you try this in C, you will see this compilation error message that we have a redefinition of a specific function. So this does not work in C, even though we have, in this case, a function without any parameters and a function with, for instance, one parameter of type int. So this does not work in C. But a very cool feature in C++, and as mentioned in many other programming languages, we can have multiple functions with the same name. But they have to be differences in the name or the types of the parameters, the numbers of the parameters, and also the order of the parameters. So the name can be the same, but the functions can then be identified if you pass, for instance, a parameter of type int, if you pass no parameter at all, if you, for instance, pass a parameter, if you have another function of type string, whatever data type is available. So you can identify a function call by the name and the parameter types and number of parameters and also the order of the parameters. So that's a very cool function if you want to have functions that behave differently based on the parameters, if there are any, that are passed to the function. So a very cool feature that is quite commonly used. I think it also makes sense in the practicals to use it. And yeah, I definitely miss this in C. So we have multiple functions with the same name, and we can also have default parameter values. So when we define a function with the name and some parameters, we can now assign a default value for some specific parameters. So this means you can call a function now by the function name without any parameters, if there are default parameters, for instance. At least not with all parameters. And what is important here, the parameters with default values have to be at the very end of the function. So you cannot have one parameter without a default value, one parameter with a default value, and then once again a parameter without a default value. So all parameters that have a default value in the function signature have to be at the end of the parameter list. So that's very important here. And we have one example here for just one default parameter. So we have the function add, then the parameter a of type int, and the parameter b of, b of type int with the default parameter value 10. This means we can now call here the function add, either with one argument here, in this case 5. This means we call the function add with the value 5 for a, and we do not pass any second argument to the function. So we now know that b will be then as a default value when the function is called without any parameters that have a default parameter. And we have here a second function called for add, but now we have two arguments that we pass. So we pass 5 for a, and we also pass 5 for b. And if we pass an argument for a parameter that has a default value, the default value is overwritten, and the argument that is passed to the function is then used for this parameter here. Yes?
Can I use also as a type in this?
That's a very good question.
So you mean
yes.
you mean here? It's basically the same as a usual function or a variable declaration. Yeah.
But you cannot have two functions with the same name and, for instance, one parameter of type auto. So there is no difference between these two function signatures then. But yeah, you can use auto, for instance. Any other questions? No. Yeah.
If I have like two default values, it will take from left to right if I just use 2 instead of 3, for example.
From left to right. Yeah.
So we have that in this slide.
You mean if
Next
there?
slide,
Yeah. Okay.
So from right
Right to left. Yeah.
So default parameters always have to be at the end of all parameters.
There was another question somewhere. Yeah. That's a very good question. I hope I understood it correctly. If you pass an argument, is this then, for instance, here always a? Is this what you mean? So if you call this function with just one argument here, with 5, then this is the value. The second one? Yes. No, it's always a in this case, because the first argument that is passed is then assigned to the parameter a here, and the second one is then assigned to b here. So the order of the arguments that are passed is relevant. Sorry? That's
No.
what you mean? No.
Okay.
Yep. Yep.
No, you cannot say at the function call here, A is equal to 5, B is equal to like this. Like in other languages,
Yeah.
for example, in Python, it's possible, I think. That's not possible in C++.
Okay. Yeah.
So you should either leave the default value variables at the very end so that we don't have to enter them, or if they are in the middle of variables that are needed, we must enter it every time. For example, if you have like A, B, and C, and the B has a default value, if you want to add A and C in the function call, we have to specify what B is. But if you don't want to have to specify that, we can just move it to the end to be the last parameter.
Yeah, thank you for the question. If we have a parameter with a default value in the middle of all parameters, for instance, with one parameter without a default value, then a parameter with a default value, and then a parameter without a default value. This is what you mean, right? This is not allowed actually, so all parameters that have a default value must be at the end of the function. So otherwise the compiler wouldn't know, is this now passed to the second parameter with a default value? Is this passed to the third parameter without a default value? So it has to be at the end of the parameter list. Yes? That's a very good question. Can a parameter be a default value for another parameter? As far as I know, it can't.
No, I don't think so.
We can try it out.
Let's try it out. But I don't think so. That sounds very, very odd.
To be honest, I haven't tried this.
Let's say A is, int A is equal to 10, and then int B is equal to A. Something like this, right? No. Oh, sorry. Yeah. No. It's undefined at this. So it actually gets created after the function is created. So it lies inside of the function. You cannot access the A variable here.
Okay. Any other questions to function overloading? Yeah, there's one question. Should we try it?
Does also not work.
Does not work, short answer, but let's see.
So you mean, for example, like this, right? So leave this first argument out and only hand over the second one. Does not work. Yeah, so you have to specify it like this. Also, if the first one is not a default parameter, it should also not work. It just does not work in C++. I'm sorry. It will work in other languages, but it just will not work if you want to specify sometimes the A, sometimes the B, sometimes the C. It just not work. You have to write another function for that.
Yeah, so I think there can also be a design issue in the structure of the code if you have this situation. So, yeah. Any other questions to function overloading? Perfect.
Then let's move on to another very, very important and interesting topic, which is vectors. But first, what annoys you at arrays in C? Yes. Sorry? Malloc, yeah. Okay, yeah. So like the dynamic factor, the dynamic allocation, yeah. What else? Sorry? Keeping track of an index, yeah, that's also annoying. Also, don't really have an idea how long it is. Yes? Sorry? Sorting. Sorting an array is also, yeah, not an easy task. Yes? Not able to insert at a specific element, yes. That's the main issue, I think. Yeah, so you cannot change the size. You have no checks on the boundary, so you don't know how big it is unless you actually defined it. You must know the size at the beginning. So at creation time, I have to know how big it is. And if I want to make it bigger, I create a new array and copy everything in the new array, or use malloc or realloc for that. It's also, not that easy. You have no copy mechanism, no length information, and the dynamic size is hard to implement. That's just a few things that are annoying at arrays. And the good news now is we have vectors, and vector is a resizable array storing multiple elements like the array of the same data type. So this is now the solution for all the problems we discussed now. How does it look like? I must admit it's not that easy to write, but you will get used to it. At first, you have to implement the vector library. So include the vector library. Don't have to implement it, just include it is sufficient. Then you just write std double column vector, so that's the data type. And then you use these angle brackets here to define the data type of the vector. So in this case, it's an integer vector. The variable name, and then what should be the content of it. So that creates a dynamic sized array for 1, 2, 3 of type integers. And now vector provides us a lot of additional information we can use. For example, the size method. So we can call my variable name dot size, and it gives us the current size of the vector. We can call pushback. Pushback just adds an element in the end. So we don't have to make realloc, make this bigger, whatever. Just calling pushback is sufficient. Then we can do a size again, and we can see in the output the size is bigger. It's now 4 elements. And we can use the .add functionality of the vector, and this is like the index operator we had with arrays, where you have the array at point or at index 0, for example. You can use this add function to access the 0th element. In this case, it's this one here, and this is also the output. So what we also can do, and I think this was a question before, when you have vectors, we could also use for each loops. So when we want to iterate over a vector, we have again our vector v, we push back one more element, and then iterate over the elements. So what's the output here? So element will get 1, 2, 3, and 4 at some point when iterating over it, and we put it to cout. This is a huge advantage compared to the C version of that code, because the C version of that code would be, I don't know, 30 to 40 lines. Only the pushback, so creating the array or making the array bigger, is like a whole new science. And this pushback is done for us with this vector class. And then iterating over it, iterating over each element and just printing it out is also more convenient. Yes? It is kind of a replacement for arrays, yes. It has a bit of overhead, but I think it's a good trade-off because it offers so much more than arrays. Yes? Do you have to free the vector afterwards? No, if you declare it like this, you don't have to free it. It's a local variable, but it's also get destroyed as soon as this function is over. In this case, it's the main, but if you declare it in another function and the function is out, then the vector is also deleted, like an array in a specific function. But we will come to that later on, I think. I don't know if it's next week or in
Maybe
2 weeks' time. Of course, there is also the concept of heap, so dynamic memory location in C++. But also, at least in my opinion, it's much easier than in C again. So it's an improvement also using heap.
So I think there's another question here.
Yeah.
How does it look in the memory? Is it like when you add another element, will the array just be deleted and like will it set up a whole new array? Then will you like push another element?
So the question is, how does it look in the memory? I don't know if we can give the real correct answer. Internally, it is stored on the heap, but you don't know it. So it is internally what always you do in C. So you create this, in C, you create the array, let's say on the heap, and then you need to make it one bigger. So you have to call realloc, make your array bigger. This is all done in the vector for you. You don't have to think about this. Good question. Is there a possibility to insert at the first position or at any other position except the last position? Not really insert, but of course you can access specific elements and override it. But inserting, is there an insert? I don't think there's an insert method for vector.
Don't think so, yeah.
Let's move. So there is a documentation. And when we go to this documentation, I just want to show you this once. There's a lot of information in this documentation, of course. And this is the documentation of the vector. And most of it, I think, will be too much for today. But what you have here is a list of operations you have in a vector. For example, this add. We have a front to access the first element, a back. We have a data option, so we write this v.data to get the underlying storage, for example, and so much more. You have here a reverse, for example, but I think, oh, there's an insert. Yeah, there's an insert. So,
But I think it's not that straightforward. I think you need an iterator, so...
You see, this documentation is maybe not so easy to read, especially in the beginning. But there is an insert, but I think it's too much to discuss this now. Yeah. But if you're curious about this kind of stuff, go to the documentation or Stack Overflow, ChatGPT, whatever. Yes?
Will we use a traditional array from C again?
Will we use a traditional array from C again? You can, but in 99% of the cases, you don't have to anymore with vectors. Yeah. Yes?
You have to define the variable type of the vector, or you just have it open and have different types of variables in a vector?
Okay, so the question is, can we kind of mix what is in here? So for example, strings with integers. No, that does not work. Unfortunately, like in other languages, we have to stick to one data type, and this always should be one data type inside.
But can we use auto as a data type here?
That's a good question. Let's try it out. std vector auto v, and then let's do something like this. No. Oh, did they have include? No, sorry, I didn't include the vector. Vector. No, does not work. Auto is not allowed here. That's a good hint. Yeah, so you have to write integer, or when you want to have floats, have to write float, but you have to declare explicitly what you want to have here. Okay, so to sum it up, we have creation initialization like this. There are many ways to create vectors. This is just one way. We will see others maybe next time also when we talk about classes. We can access elements with this add. We could also access elements with the traditional way like this. This will also work, but we would recommend to use this version, because when you exit this, like when you access the array and it is out of bounds, so let's say you access the 10th array element, this one will give you a segmentation fault. Basically, your program crashes. This one will give you a so-called exception. We will talk about this in a few weeks, but the difference is you have the possibility to work with this exception, and your program does not crash immediately. You can catch this exception, so you can interpret it and work with it. So this is more type safe. We can add elements in the end, and we can define the size of an element. That's also very, very cool, because most of the time with C arrays, it was hard to identify how big my array is now. So you have to hold the size of an array in another variable, and this was also, hard, in my opinion. All right, the next quiz. About vectors, we have a vector here, we have a function which adds one element, and then for each loop iterating over the vector, what's the output?
It's again a tricky one.
Is it?
I think so, yeah. So it'll be interesting to see what exactly happens if we pass the vector and then modify it in the function. Let's see. Yes?
Sorry, once again? In general, you can declare a pointer to an object, yes, and also a reference to an object.
This standard vector is an object, because is the name of this vector a pointer to this object?
That's actually the question in this case, yes. So this is what you should scratch your head about. Okay, few more seconds. Please decide for one solution. You will not get punished if it's wrong, don't worry. Okay. What have you decided to? Wow.
That's Fantastic.
Wow, great. Yeah, so they know us maybe, and they know that we will trick them in some way. It's 1, 2, 3. Why is this the case? So we have a vector here, vector of 1, 2, 3. We call this add element function, and you paid attention to my reference part before, because this one here gets copied. So the whole vector, in this case it's just 3 elements, but the whole vector gets copied. We add 1 element to the copy of the vector, and this copy gets deleted when this function is over. So we iterate over the original vector here. How can we solve this? Any ideas? Yes. So we simply add here a reference symbol. And this now means that the vector doesn't get copied. It's the same vector we are working here with. And this has 2 advantages. The first one is, of course, we can modify the original vector. The second one is it needs, maybe not in this case, but if you have a large vector, it consumes a lot of time to copy large vectors. Let's say this vector has 1 million entries. You have to copy 1 million entries every time you call a function and hand over this vector. So usually, in most of the cases, you should use references to reduce the amount of copying and will also save a lot of time. So I think in most cases, you want to work with the original vector and don't want to work with a copy of it. Sometimes, yeah, it might be beneficial, but in most of the cases, use the references here. Okay, then let's come to our last topic, strings. Or are there any questions to vectors in general? Yes. Sorry, I didn't get it. Can you simply return a vector? Yes, you can return a vector, but again, a vector is like a local variable when it's on or inside a function declared. It's deleted as soon as the function is over. Mm-hmm. I don't know. I think you are a bit, yeah. What if we return a reference? Yes, you should also return a reference, but you should not return a reference to a non-existing vector. Yeah, so the vector gets deleted no matter if you return a reference. This will result in at least a compiler warning, maybe also compiler error. Yeah, and it crashes, of course, because you're accessing elements which are not there anymore. Yes? Can you put vectors into vectors? Yes, of course you can. You can also put vectors into vectors into vectors. You can make a 2D array or 2D vector, as we know from arrays. You can make it 3D, 4D, whatever you want. But the declaration here can get very messy then. Yeah, but it works. Yes? Yeah, there are. I think we saw it. Oh, I already closed it. No, it was. There are. I don't know if pop is inside, but there are like front and back. I think there is a pop. Yeah. Pop back.
It's the pop back.
Pop back, it's called. Yeah. It removes the last element. All right. In interest of time, maybe we should continue to our last topic, which is strings. Again, the same as in C. what annoys you with C strings, C++ will have so much convenient features. Remembering concatenating strings in C, for example, you have to make sure that this string 1 is large enough if you want to call strcat, so to concatenate the second one to the first one, and this can be annoying. But more importantly, for example, comparing strings can lead to a function like this if you don't use strucompare. So comparing strings in C is, a pain.
Mm.
What does C++ for us? C++ has, again, a functionality called std string, and this is kind of a wrapper around a C string. You again have, like in the vector, a dynamic size, so you don't have to resize your character arrays. You don't need to manage the memory by yourself, and there is again a lot of predefined operations similar to the vector ones. So basically a string is kind of a vector because it just is a vector with characters inside. So creating a string is std string, str, and then as we know it from C. You can access elements again using this at. You can infer the size or the length, so these both functionalities from the string returns the current length. I don't know where there are two. I think it has historical reasons. Yeah. Some people like size, some people like length, but they actually return the same. And you can access also the underlying C array if you want to modify or whatever, work with it. Maybe you want to have the C array and store it into a char pointer, so you can also get access to the C array. But in most cases, you will work with the string. So for example, when you want to concatenate a string, you can just write str and create this string, then create a second string, and you can just write str plus str2. In C, this would add the two addresses. In C++, luckily, it will, or it does that what we want to do. We concatenate the second string to the first string and store the result in this first string. Comparing strings was also very, very hard to implement. Now it works as with every other variables, just using if name1 is equal to name2, and in this case the output is equal. So in C we compared here the pointers. In C++ we are actually comparing what we want to compare, the content of the string. We can do a lot of string manipulations, so we can, that's not correct, that's not accessing elements, I'm sorry, that's of course clearing, so removing the whole content. You can again also push back, so add one character at the end. You can add more than one character and add another string, like using the append method. You can use find. That's also an implementation in the str functionality. And the find method gives you the opportunity to find a substring and then returns it. It returns the position where it occurs. So, for example, we have our string, hello OOP, and then let me find the position where the P1 is inside. In this case, it's the 9th position because it's the 9th character here. If it does not occur inside the string, then a so-called std string npos is returned, which basically means it's not found. And you can again check if this pos or this value here is equal to std string npos, then you know it was not found inside. Another cool feature is cutting strings using the substring method. So what you can do is you can define a start and a length, and it returns you the smaller part of it. So let's say we have again our hello OOP. Then we say in our string, give me the characters from 7 and then 3 characters, and then it will return OOP because this one is the 7th, 8, 9, and then it will cut also in the end. Very nice feature if you work with strings. Remember doing this in C. I don't want to remember, but it is a lot of work again to do. Okay, we can also combine this, and let's say we have our string. This is very, very common also for me, because sometimes you have names written like this, but you want to write it in another way. So what we can do is we find this underscore here, use the position where it is, and then create substrings. So basically cut out the first name from the 0 element to this position. So basically it is Tom here. We cut out the last name from this position +1, so 1 after the underscore, which is then the turbo, and then we can use it, for example, like this, and the output also works. So it's much easier to cut strings, find something, also replace something. So in this case, we could also call a so-called replace function, and then this would replace the underscore with a new line, or not with a new line, with a white space. But I just want to show you that you can, of course, combine these functions, find something, create a substring, and this will be very helpful also for the assignments. Yes, was this you? Yeah.
So if you don't do the second parameter, then it will take the whole string, or the rest of the string?
Yes, very well spotted. In this second case, there is a default parameter, and it will be until the end if we do not declare it. Yes. Any other question? The last character is still \0 because under the hood it's still a C string. But when you call length or size of the string, it omits this \0. So it actually gives you the number of characters inside. So it is basically a C string, but with a lot of functionalities we can use now. We have one more question for you about strings. Maybe also a tricky one, I don't know. Have a closer look on what we are doing. It's not that easy, maybe.
Again, a lot of discussions. It's
Yeah.
probably tricky.
There is again maybe 2 pitfalls inside.
Yep.
Okay, last seconds to vote. That's a lot of discussion. Okay, in the interest of time, I think we should stop here and let's see what you voted for. Yes, very, very good. But at least some, yeah, got it wrong, but that's fine. That's for practice here. So what's the problem here? Or at least there is no problem because actually it's printed what we want to print. This is Sparta. What are we doing here? We have this str at 0 is k. So we are modifying this one here, but we are printing out the second one. It's a copy. So what we get here is actually a copy. It's not the same str. So with this, it gets copied into the new string, so it does not affect when I change the original string. The second one is trickier here. Str2 make a substring from 0 to 2, or with 2 characters, would mean that it is T and H, because that's what's here. But it's not written somewhere. So if we are missing this one here, when we write it like this, the result of this substring is stored into the str2. Then the output is th. But when you write it like this, the output is just written nowhere. You don't catch it, and the str remains the same. Again, I know that's hard, but now you know that it works like this. Okay, to sum it up a bit.
So we have made our first steps into C++. Basically, all of the C code works in C++. Yeah, C++ is built on top of C, so it must work. And we have now learned a lot of cool features, a lot of cool concepts that we will use in all further lectures, also in the practicals. So for instance, we have learned about references that we can use instead of pointers. We have learned about for each loops, so range-based loops. We have learned about auto, so do not have to write the data type each time. We have learned about function overloading, to have multiple functions with the same name but different parameters. We've learned about the cool containers, vectors, and strings, which are very powerful and make life, in my opinion, a lot easier. And there is a lot more to come next time when we will introduce classes and
next time we go into object-oriented programming.
Exactly.
That would be it will be interesting. So thank you for being here and see you next week.
Thank you. Bye.